All right, guys, today we are going to talk about measuring flow rate over an orifice plate using a differential pressure transmitter. There's a fairly complicated formula to go along with this. So the first part of this video, we're going to go ahead and we're going to break that formula down and show you how to perform those calculations. So this formula up here is Q is equal to 5.667 times S times D squared times the square root of H over G sub F. Sounds like a lot of variables, and it really is, but at the end of the day, we're going to simplify those here just a little bit. Q is the gallon per minute. That's basically how many gallons per minute do we want to perform this calculation for. So we can pick that, whatever we decide to. So for example, on our flow rig here, we decided to go with 13 gallon per minute. That's a little bit above what we can actually push through that pipe. So we want to make sure we can capture the full range, and that's really how we decided to go with 13 gallon per minute. 5.667 is a constant in the formula. S is a sizing factor. We're going to come back to S because it takes a little bit to come up with S. The big D squared, the big D is the inside diameter of your pipe. We've got 3/4 inch PVC, and so the inside diameter of 3/4 inch Schedule 40 PVC is 0.804 inches. Okay, and the last part of this formula is the square root of H over G sub H over G sub F. H being height in inches of water, that being the pressure we're going to put in the transmitter. G sub F is the specific gravity of our process fluid. So if we actually have water, specific gravity would be 1.0 over here. And so it would be H over 1 at that point, which is essentially just H. So since we're doing water, we're going to get rid of the lower half of this equation and just run with H when we get down here a little further. All right? So the challenge is we're going to go ahead and start plugging some numbers into this. I said that Q we knew already, and we do. It's 13 gallons a minute. So we're going to plug that into the formula. 5.667, that is our constant. That doesn't change. That's just plugged in there. This number right here is S, the sizing factor. We need to go equate that. So we're going to back up over here, and I'm going to show you how we came up with that. So the sizing factor is in a table. And to pull that number out of the table here, you need to know what the beta is. And the beta is actually the D to D ratio. Now this little d here, right up here, is the orifice diameter. So that restriction that we put in the pipe, that orifice plate, actually has a hole in it that is 0.5025 inches in diameter. How do we know that? Keith and I just drilled that hole today, all right? I measured it with a digital caliper, and it came up exactly to that. That's what we were looking for, actually, and it worked out pretty good. So the little d is your orifice diameter, the big D is the inside diameter pipe, like we talked over there. And Schedule 40 PVC 3/4 inch is 0.804 for an ID. So D to D ratio is literally little d divided by big D. And if you divide those two out, down here you can see that D to D comes up to be 0.5025 divided by 0.804, and we come up with 0.625 for a beta. Now you got to take your beta back to this table right here, and you got to look across to the other side and see what sizing factor number lines up with your beta. So at 625 beta, we come up with a sizing factor of 0.2614. So we've taken that and we've gone over here and plugged that into our formula where the S sits. So now we have sizing. Now the next thing over here is the big D squared, the inside pipe diameter squared, all right, 804 squared. And then again, we're over here with H over G sub F. Like I said, water's 1. We're going to simplify this down to H as we start simplifying this formula. So what I did, went ahead and took all three of these values, multiplied them out, crunched them down, and dropped them right into here. 0.95757 was that value of that product there when you multiply them all out. And then times the square root of H here, okay? So we had 13 over here. So it was 13 is equal to 0.95757 times the square root of h. You simplify this down, you divide both sides by that, this cancels out, and if you divide 13 by this, you come up with 13.57 is equal to the square root of h, and then if you square both sides of this equation, you get h, and then squaring 13.57 gives us 184.1 inches. So that means that we have 184.1 inches of pressure drop across that orifice plate at 13 gallons per minute, okay? 13 gallons per minute. So I can go anywhere from 0 to 13 gallons per minute, and I can plug that number into this formula, and I can tell you what the pressure drop would be at 6 gallons a minute, or 3 gallons a minute, or 7 gallons a minute, okay? What we want to do, though, is we want to find out what our pressure drop is at our maximum value. This 184 inches, 13 gallons per minute. Okay, these are what we got to put in our DP transmitter for our upper range value, our maximum pressure drop. All right, so that is it on the calculation. Now we're going to walk you over there and walk you through the heart communicator, how to set this up.